I'd like to graph one rational function with you. This video does assume that you understand the basics of graphing rational functions. But let's jump in. We're going to find the asymptotes and intercepts and then graph the function. And it's f of x equals x squared minus 4x plus 4 over x squared minus 9. Now I know we'll be looking for the vertical asymptotes first, so why don't we factor? So in the denominator, we have x plus 3 times x minus 3. And I'm going to factor the numerator as well, because after all, in order to confirm that we have a vertical asymptote at a particular place, we have to make sure that that factor doesn't also exist in the numerator. Notice the numerator factors into x minus 2 times x minus 2, and I'll just write that as x minus 2 squared. So in fact, I have no common factor in the numerator and denominator, so I know the vertical asymptotes are at x equals negative 3 and x equals positive 3. Let's move on to horizontal asymptotes. The degree of the numerator is the same as the degree of the denominator. So I look at the coefficients of x squared in both the numerator and denominator. The coefficient is a 1 in the numerator and it's a 1 in the denominator. So I know I have a horizontal asymptote at y equals 1 over 1, which is just 1. Since I have a horizontal asymptote, I know I do not have an oblique or slant asymptote, so I would just write none. Let's move on to x-intercepts. We find our x-intercepts by setting y equal to 0, in this case f of x. I can use either version of this function I like, the first one or the second one. I kind of like the second one. So I'm going to write it as 0 equals x minus 2 squared over x plus 3 times x minus 3. We multiply both sides by x plus 3 times x minus 3, and we get 0 equals x minus 2 squared. When we take the square root of both sides, that plus or minus is not going to do a whole lot, because plus or minus 0 still gives you 0. So I have x minus 2 equals 0, and I get x equals 2. And let's write that as an ordered pair to keep it distinct from our lines above where the equations represented asymptotes. So this one will be the point 2, 0. Let's find the y-intercept. So we set x equal to 0. So that's 0 squared minus 4 times 0 plus 4. Over 0 squared minus 9, and I get y equals 4 over negative 9, or negative 4/9. Again, I'm going to write that as an ordered pair, so I have 0, negative 4/9. Now we're going to put all of this information on our graph. So let's start with the vertical asymptotes. I have a vertical asymptote at 3 and negative 3. And I'm going to be careful, so I'm going to mark my grid here. Here's 1, 2, 3, and here's negative 1, negative 2, negative 3. Let's just label those. And I'm going to put in my vertical asymptotes. Here's the second one. And we have a horizontal asymptote at y equals 1. So let's put that in. And we're going to keep in mind that those asymptotes are our graphing guides. But we have a little bit more to put on our grid before we start seeing what the curve will look like. We have an x-intercept at 2, 0, so let me write that right here. And we have a y-intercept at negative 4/9. That's really close to negative 1/2, so I'll put it about right here. Negative 1 would be about right here. So this is negative 4/9. And now we're going to begin our analysis to figure out what this looks like. Remember, the vertical asymptotes chop up your plane. So I know I have 3 distinct parts to this rational function graph. I have a part over here to the left of negative 3. I have a piece in here between negative 3 and 3. And I have a part of the graph to the right of 3. So let's start in between negative 3 and 3 because we have a couple of points. And we know that our graph is going to need to go through those 2 points, so I'm going to just connect them right here. Now, I know I do not have any more x-intercepts, so at this point I'm deciding, do I go down or do I turn and go back up? If I turned and went back up, I would be crossing the x-axis and I have no more x-intercepts, so I know the graph must be approaching the asymptote this way. Now, at 2, I need to determine whether it crosses or just touches at 2. Because our graph could head up this direction, as they do sometimes, or it could head down this direction. Let's come back over here and look. Notice this 2 came from this factor, x minus 2, which is raised to an even power. And because it's raised to an even power, we know the graph is just going to touch the x-axis at that point and turn back around. It will not cross. So I'm going to erase that part where it looks like it was going to go up as I was considering that. So let me erase that since I know that doesn't happen. And we now know the graph will head this direction and get ever closer to that asymptote. And notice it's not very symmetric there, but that's fine. Now we need to consider the graph to the right of 3 and to the left of negative 3. We have our asymptotes as our graphing guides. So consider to the right of 3. The graph could look like this, or it could look like this. Do you see why it cannot cross the x-axis? We don't have any more x-intercepts, so it cannot be the one that's below. So let me erase that. For the same reason, the part of the graph to the left of negative 3 must also live up here because it can't cross the x-axis. But we have one more detail that I didn't address, and that is this. I put the pieces of the graph up completely above the line y equals 1, and we don't know whether that actually happens because the graph can come below that asymptote and then come back up and approach from beneath. So which does it do? Does it look like this or does it look like this? And similarly over here on this side, the graph could approach the asymptote from above or it could approach the asymptote from below. So our job now is to see whether the graph crosses the horizontal asymptote. So let me write that. Does the graph cross the horizontal asymptote? And in this case, that means, is there a point on the curve in which the y value equals 1? In other words, is there a point that exists on the graph that would look like this? Let's see if we can find one. Since our horizontal asymptote is at y equals 1, we're going to set the function equal to 1. So I have 1 equals x squared minus 4x plus 4 over x squared minus 9. Let's multiply both sides by x squared minus 9 to solve this equation. So I have x squared minus 9 equals x squared minus 4x plus 4. So negative 9 equals negative 4x plus 4. And I have negative 4x equals negative 13. Let me move over here. I have 13/4 equals x. And just because I need to know where that is on my graph, I'm going to convert that to a mixed number. That is 3 1/4. So in fact, we know the graph does cross the horizontal asymptote. It does at 3 1/4. So let's see where that is. Let me come over here. 3 1/4 is actually right here. That means the graph has a point right here. So it looks like, number one, it's going to hug the asymptote a little bit closer, but we do know, in fact, that there is a point where the graph will cross that horizontal asymptote. So let's put that in right here, and I'm going to erase and make it look a little bit better. Notice we don't have any other x values for which y equals 1. This is the only place that happens. So that means over here on the left, it will not cross the asymptote. I'd like to mention one more thing. Suppose you like to use the interval testing to help you determine whether the graph is above or below the x-axis. That would work great in this problem. You would have had 2, 3, and negative 3 as your critical values. You would have determined that it was above, below, below, and above. And notice that matches what we have on our graph. What it does not tell you, though, is whether the graph would cross the horizontal asymptote. When we have a plus here, that means it's above the x-axis. It does not tell you whether it's above the horizontal asymptote when the horizontal asymptote is at 1. So you can use this to help you graph, and that's not a bad plan to use this in conjunction with the other things that we discussed, but it wouldn't address does it cross the horizontal asymptote. And here I wanted you to see that the graph really does look like we have it graphed by hand. Here's how it looks when the computer does it. I hope this helps.